Problem number 1 for airfoil pressure distribution. So, problem is an airplane is flying at an altitude of 3,500 meters at an airspeed of 300 meter per second. So, find the critical velocity, critical pressure, and critical pressure coefficient. Okay? So, pinapahanap sa problem yung critical velocity, critical pressure, and critical pressure ng aircraft na lumilipad sa altitude na 3,500 meters. And meron siyang airspeed, meron airspeed yung aircraft ng 300 meter per seconds. Okay, so first of all, sulat muna natin yung given. So, given altitude 3,500 meters, then airspeed, okay, V, airspeed is 300 meter per seconds. Okay, so required, sulat natin yung required. Yung pinapahanap is VCR, okay, critical velocity, then critical pressure, PCR, and critical pressure coefficient. Okay, so C sub C sub CR. Okay, so itong tatlo ngayon yung hanapin natin. Solution. First of all, for unahin natin kunin yung critical velocity. Okay? So V sub CR, ito yung critical velocity, yung formula niya, 'di ba? Sinabi ko na sa discussion natin sa PowerPoint. VA infinite times M infinite squared plus 5 all over 6 times raised to 1/2. Okay? So, itong VA infinite, ito yung speed of sound. Then, M infinite, ito yung Mach number. Okay? Ulitin ko lang yung infinite. Okay? So, sign lang yan. Okay, so sign lang yan na pwedeng negative or positive yung value ng Mach number at ng speed of sound. Okay? So since sa formula ng critical velocity, hinahanap kailangan yung speed of sound and yung Mach number para makuha yung critical velocity. Okay? So kailangan muna natin kunin yung value nila, value ng Mach number and ng speed of sound. Okay? So, unahin natin kunin yung speed of sound. So, since metric system yung ginamit na unit sa problem, so VA is equals to 20.05 times square root of T. Okay? So, since sa given, walang given na temperature, pero may given na altitude, which is 3,500 meters. So, kunin muna natin yung temperature sa altitude na 3,500 meter. Okay? So, temperature variation na formula, T sub O plus AH. Okay? So, T is equals to yung constant value ng temperature at sea level condition is in metric system is 288 Kelvin. Okay? Then lapse rate, constant value ng lapse rate is sa metric unit system is negative 0.00651. Okay? Kelvin per meter. Then H, ito yung altitude na 3,500 meters. Okay? So, T, kuha na natin temperature ngayon. Equal siya sa 265.22 Kelvin. Okay? So, since nakuha na natin yung temperature sa altitude na 3,500 meter, substitute lang natin ngayon yung temperature dito sa formula ng speed of sound. Okay? So, VA equals to 20.05 times 265.22 Kelvin. Okay? So, VA equals to 326.52 meter per seconds. Okay? So, nakuha na natin ngayon yung value ng speed of sound sa formula ng critical velocity. Ngayon, kukunin naman natin yung Mach number. Okay? So, ang tatandaan nyo, yung formula ng Mach number is M equals to V over VA. Okay? So, sa problem, may given na tayo na 300 meter per second na airspeed ng aircraft. Okay? Then, may given na din tayo, nakuha na natin yung speed of sound ng air, which is 326.52 meter per second. Okay? So, substitute lang natin ngayon yung mga value. So, V, 300 meter per second over 326.52 meter per seconds. Then, cancel lang yung unit. Okay, so Mach number ngayon is equal sa 0.918. Okay, so ngayon, nakuha natin value ng Mach number. Substitute lang natin ngayon sa formula ng critical velocity. Okay, pati yung speed of sound. Substitute lang natin. So, V sub CR is equals to, ito, ayun, nakuha nating speed of sound ng air, which is, ito, 326.52 meter per seconds, okay, times, yung Mach number na nakuha natin kanina, 0.918 squared, plus 5. Okay, sinasubstitute lang natin yung mga value sa formula ng critical velocity. Over 6 raised to 1/2. Okay, so direct sub lang yan sa calcu. Makukuha na natin yung value ng critical velocity. Okay, so V sub CR is equals to 322.21 meter per seconds. Okay, so yung unit ng critical velocity in metric is meter per seconds. In English system naman is feet per seconds. Okay? So, nakuha na natin itong critical velocity. Next naman is critical pressure naman. Okay? So, itataas ko lang to. So, for critical pressure, P sub CR. Okay? So, formula ng critical pressure is P sub CR equals to P infinite, okay, times M infinite squared plus 5 all over 6 raised to 3.5. Okay? Yan yung formula ng critical pressure. Okay? So, M infinite, Mach number yan. P infinite, yan yung pressure yan yung pressure dun sa altitude kung saan lumilipad yung aircraft. Okay? So, kunin natin ngayon yung value ng P infinite. Okay? So, yung Mach number, meron na tayo. Nakuha na natin kanina, which is 0.918. So, kunin na lang natin ngayon yung pressure sa altitude na 3,500 meters. Okay? So, gamitin natin ngayon yung formula ng pressure variation. Okay? So, P infinite is equals to P sub O plus, times 1 plus AH over T sub O raised to 5.26. Okay? So, yung formula na to, ito yung formula sa aerodynamics nyo para kunin yung pressure at a certain altitude. Okay? So, P sub O, ito yung constant pressure sa sea level condition. Okay? So, since metric system tayo, so yung value ng pressure sa tawag dito, sea level condition is 101,325 Newton per meter squared. Okay? So, times 1 plus A, value ng lapse rate sa metric system, constant value ng lapse rate is negative 0.00651 Kelvin per meter. Okay? Times yung altitude, itong age, yung altitude na given sa problem na 3,500 meter. So, 3,500 meter all over T sub O, yung constant value ng temperature sa standard sea level condition is 288 Kelvin. Okay? So, yan. Substitute lang natin raised to 5.26. Substitute lang natin yan sa calcu para makuha yung pressure sa 3,500 meters na altitude. Okay, so P infinite now is, wait lang, substitute ko lang sa calcu. (0.00651 times 35288 raised to 5.26. Okay? So yung value ng P infinite ng pressure sa 3,500 meters is 65,680.74 Newton per square meter. Okay? So, since nakuha na natin yung P infinite, substitute lang natin ngayon sa formula ng critical pressure. Okay? So, P sub CR is equals to, okay, yung value ng P infinite, ito, 65,680.74 Newton per meter squared. Okay? Times M infinite squared, yung value ng Mach number natin kanina, which is 0.918. Okay? So 0.918 squared plus 5 all over 6 times raised to 3.5. Okay? So, direct sub lang yan sa calcu. Makukuha na natin yung value ng critical pressure. Okay? So, P sub CR is equals to, wait, lagay ko lang sa calcio. 59,981.66 Newton per meter squared. Okay? Kapag English system yan, yung unit ng P sub CR is pound per foot squared. Okay? So, always box your final answer. Okay? So, nakuha na natin yung V sub CR, critical velocity, tsaka yung critical pressure. So, last, nakukunin natin is yung critical pressure coefficient. Okay? Ibaba ko lang. So, formula ng critical pressure coefficient. Okay? So, for C sub P sub CR, okay, formula ng critical pressure coefficient is C sub P sub CR is equals to 5 plus m infinite squared over 6, okay, raised to 3.5 minus 1 all over 0.7 m infinite squared. Okay? So, sa formula ng critical pressure coefficient, Mach number lang yung kailangan. Okay? So, nakuha na natin yung Mach number kanina na 0.918. So, direct sub lang. Substitute lang natin yung value ng Mach number. Okay? So, C sub P sub CR. Okay, itong C sub P sub CR, ito yung critical pressure coefficient. Okay? So, substitute lang natin sa formula yung value ng Mach number. So, 5 plus 0.918 squared, okay, over 6 raised to 3.5 minus 1. Okay, all over 0.7 times 0.918 squared. Okay, so direct sub lang to sa calcu, makukuha na natin yung value ng critical pressure coefficient. Okay, so dito ko na lang ilagay, di na siya kasya. So C sub P sub CR. So yung critical pressure coefficient is laging unitless. Okay, so walang unit yung critical pressure coefficient. Then laging negative. Okay, so laging negative yung sagot sa critical pressure coefficient. Okay, so direct sub ko lang sa calcu. Wait lang. So 5 plus 0.918 squared all over 6 raised to 3.5 minus 1 all over 0.7 times 0.918 squared is equals to negative 0.1150. Okay? So, ayan lang.